Alright, next up is an A1502 that claims it has no power. Let's try and figure out what's wrong with this A1502 that has no power by opening it up. I've opened up the A1502 with no power. Now we're going to plug it in and see what happens. Let's see how many amps this thing uses, if any. This uses 70 milliamps, but doesn't turn on. Wonder if we have a similar Allsys power good problem to what we had before. So this board is an 820-4924, whereas HAKKO would call it a Texas Instruments graphing calculator. Let's see what's wrong with this MacBook. So let's go and check out our power rails. The first thing we're going to check is our PP bus. All aboard the PP bus. 12.6 volts on PP bus. Good. Let's check some other rails. PP5 ES5. 5.2 volts. Let's see what we get on something like PP5 ES4. 5.2 volts. Let's see what we get on something like PP5 ESO. 5.2 volts. So it seems like we're in a similar situation as to where we were with that MacBook Air board previously. We are in an SO state. If we're in an SO state, that means all of our S3, S4, S5, and G3 hot rails are present, which means we don't have to waste time checking everything on this list, because that would be quite a bit of time. So what we're going to do now is we're only going to check SO rails, and I'm also going to check the Allsys power good signal to see if that's present, because when all of our SO rails are present, Allsys power good is supposed to come high, and when that comes high, we're supposed to be getting CPU vCore. So let's take a look for Allsys power good in our schematic. Now you'll see that Q8150 here is very similar to the Air of the same year. It's actually the same chip and virtually the same circuit. So let's see what's going on with our Allsys power good and see if my system's power is actually all good. Let's get the microscope open, roll over to the Allsys power good area, and we're missing Allsys power good. Allsys power good is 0.1 volts. No good. Let's go through all the rails required. So we checked PP5 ESO. Now we're going to check PEPA3v3 ESO. Wow, PEPA3v3 ESO is almost everywhere. PEPA3v3 ESO is 0.6 volts. That's no good. 0.6 volts on PEPA3v3 ESO. So now what I'm going to do is I'm going to see if there's a short to ground on PEPA3v3 ESO. No short to ground, 2 kiloohms, that looks fine. So now we're going to search down on our list of rails. Is PEPA3v3 S3 there? Is PEPA3v3 S4 there? Is PEPA3v3 S5 there? And so on and so forth. Now, my guess is that PEPA3v3 S5 is there because PEPA3v3 S5 is going to be used for all those PCH signals like PM Sleep S4L, PM Sleep S3L, and so on and so forth that are required to get all the other S4 and S3 and SO rails. So I'm probably not even going to bother to check that. What I am interested in is PEPA3v3 S4, PEPA3v3 S3, and what's going on from there. Now, just to be complete with everything so I don't get trolled, even though I know PEPA3v3 S5 is there, I'm going to check PEPA3v3 S5 just to make sure, as I said, that I'm not being trolled. You never know when trolling is occurring, especially when punching sweet is in your chat. So we are getting, for PEPA3v3 S5, 3.35 volts. Now we're going to check PEPA3v3 S4. 3.3. Now we're going to check PEPA3v3 S3. PEPA3v3 S3 can be found up here. PEPA3v3 S3 is there. I actually kind of started to like the RGB. It started to grow on me. RGB. Makes me happy. What we need to do here is figure out where PEPA3v3 SO comes from. So we have to find out where it's created. So that means going through the entire schematic, piece by piece, and searching. Now this is where PP3v3 SO is going into something. Not interested in that. Not interested in that. All the things I'm clicking past right now is where PP3v3 SO is going into something. I want to see where PP3v3 SO is coming out of so that I can see what's creating it. Understand? Here we go. 3v3 SO switch. So this is going to be what allows PEPA3v3 SO to be created. So when you have a signal here at the on pin, PEPA3v3 SO is going to turn on. Let's take a look at what U8030 looks like on this board. It's going to be right in the middle section over here. This thing over here is going to be responsible for creating PEPA3v3 SO. So what we need to do here is see if we're getting PEPA3v3 SO enabled, the signal that tells it to turn on. So that can be measured right under the chip on this capacitor over here. So let's measure it on that capacitor. 3.3 volts. So it's being told to create it, but it's not creating it. Very interesting. Now, voltage out. PP3v3 S5 goes in, and then PP3v3 SO fed is supposed to come out, but it doesn't, which means that most likely our issue is with this little chip. Does it look bad at all?
Shorted or you shorted? So it's this and this.
Yeah. That was
By the way, if you're watching this video on Vimeo, you may notice that the quality looks better than it does on YouTube. Check out vimeo.com/Rossman Group, or you can go to boards.rossmangroup.com, where you can browse through every single one of our logic board repair videos by either the model number of the board or the type of the problem. Don't delay. Check us out at boards.rossmangroup.com today to find our videos without ads and in higher video quality. Bye-bye, little chip. God, you bastard. Stay, you bastard. Flux that's so good, PostNord steals it every time it's shipped. Alright, so we're going to plug this thing in. Let's see what we get on output. PP3V3SO is 3.3 volts. Beautiful. All-sys power good is 3.3 volts. Beautiful. The final test. This is how we know that this is actually done. Fan spin. So it seems like we were grabbing 70 to 90 milliamps, which is common when you're missing one of the SO rails, but the other SO rails are present. That's been a pattern that I've talked about in many of the SO rails missing videos. I've talked about how it is you can hook up a DC power supply to the machine. You could just look at my video how to hook up a MacBook charger to a DC power supply. This way you can read exactly how many amps are being used. It's helpful in troubleshooting. And I went to All-Sys Power Good and I noticed that all the rails were present besides one, and that All-Sys Power Good was missing. We then traced back, so PP3V3SO was missing. PP3V3S5 was present, PP3V3S4 and 3 were present, PP3V3SO was not. So we checked for a short circuit to ground. There was no short circuit to ground, meaning the rail was just likely not being created. So when we look at the schematic, this is going to be the junction at which PP3V3S5 is going to turn to PP3V3SO. Now, we had to see if this chip was being told to turn on. Thank you very much, UK Rossinator. It's very kind of you. We saw that this enable was present. So it says P3V3SO enable. That's going to the on pin of the chip, which is going to be obviously the pin that turns it on. You don't got to be an electronics engineer to figure that one out. And U8030 over here was broken. Even though it didn't look broken, it was broken. And when we replaced it, we got fan spin. Since we have fan spin, we can be guaranteed that this works without any sort of further testing or quality assurance. And if you want to watch these videos in higher quality, check out vimeo.com/Rossman Group, where you can watch them with no pre-roll or post-roll or banner ads. On the video itself, higher bit rates, better streaming. And above all, you can see on boards.rossmangroup.com where all these videos, including the last 5 years in the archive, are not only sorted by board model number, they're also sorted by board problem type, and they're hosted there just in case YouTube decides to be a fuckboy and do something screwy. So that's it for today, and as always, I hope you learned something.